Now, today I'm going to cover soil organic matter, which is essentially the bigger part of what we learned 2 days ago, soil biology. Because soil organic matter encompasses something organic that consists of majority carbon, whether they live inside the soil or the dead matter coming from those things. So I don't think I need too much of introduction because from day one, I already told you so many things about soil organic matter. The first day when you were out taking soil samples, I told you that, okay, what's good sample? What's good soil sample? They will be dark in color. Why they are dark? Because they have soil organic matter. And that is why. Now, today we're going to learn in details why soil organic matter is so important for soil health. Okay, now just want to bring you to the second point. Apart from clay, soil organic matter are the chemically active ingredient of soil. Capability for exchange, cation exchange capacity, and also water retention. So basically, these are what soil organic matter are so important of. They retain two very important things for living organism, including trees, including plants, and those are moisture, water, as well as nutrient, both of which very important for photosynthesis. So you must have seen this before. By the way, this is far different than those that you have seen behind DK delta. DK delta, uh, they are naturally enhanced with organic matter because they are trees. But if you look at here, these are actually artificially enhanced. Now, meaning that this is actually a piece of soil, initially sand. If you can see bottom here, it's a bit whitish, and yeah, it is sand. Now, this picture, if not mistaken, were taken from temperate country, is not mistaken, USA, and this is part of the farmlands that they have. They actually cut it through, and then they realized that for area that has been constantly added with animal manure is like cow dung. Yeah, cow dung, where they are added consistently, they actually will have a thick horizon. Thick horizon where it consists of a lot of organic matter. And I would say that they have a very thick, abnormally thick A horizon. Because usually A horizon, they don't stretch like for more than 30 centimeter. I believe this is more or less 30 centimeter. Now, organically wise, naturally the A horizon stretches maybe around 15 centimeter, but there are some places like Sarawak actually is quite wet. It's very humid. They have the highest rainfall in Malaysia, somewhere near Kuching, maybe somewhere north, slightly northeast of Kuching. That place actually have the highest rainfall in Malaysia, and the soil there actually is consists of peat soil. How deep is that air horizon? 30 meters, up to 30 meters. So it depends. Soil organic matter, some places they have more, some places they have less, depending on the elements of the environment, the climate, as well as the geography as well. Okay. Okay, now what you can see right here is 3 vials of water extract. So we use water and we mix it with the soil, and from there you can actually extract organic matter. And these are, okay, whatever you can see inside here, they are considered as the dissolved fraction. Okay, now organic matter, initially we thought they are solid, but if you mix it with water, they can dissolve it. Why? Because if you still remember the structure, yeah, they can interact with water. They can become a little bit soluble. And the more organic matter, the darker the solution. I'll explain to you why it becomes darker. Initially, it becomes yellow and then orange and then completely brown, dark brown in color. Okay. So soil organic matter in agricultural topsoil. Topsoil means first that first 30 centimeter. Okay, first 30 centimeter from the surface of the soil. That is how deep. Okay, and then the content is between 1 to 6% in weight. Then I told you if it is peat soil, it could be more than that. Agricultural soil, non-peat soil usually is within that range. Okay, this amount is the result of all addition and losses of soil organic matter that have occurred over the years. Now, there's one more thing that you have to remember is that soil organic matter is organic, bacteria can attack it, or not just bacteria, any microbes can actually degrade it, including sunlight. Even sunlight also can degrade organic matter. Now, the point that I'm going to raise here is that organic matter do not stay forever in the soil. The moment you add it in, it will be degraded. And then during the degradation process, slowly they lose their weight. They becomes weaker and weaker in terms of their bondings, and then they will lose. They will be lost in the form of carbon dioxide or anything else, but mostly carbon dioxide lah, yeah, due to respiration. So these things will be lost over the time, but naturally, you have trees, you have plants that grows on the surface of the soil. So the organic matter will also be replenished by these trees. Yeah. So you can say that organic matter seems like a cycle in the environment. Now, in this case, in the soil, very much like the cycles of water. Okay, water on the surface of the earth. Now, I think this one, you already did it, kan? LOI, loss on ignition. By the way, that is one of the easiest way to know what is a soil organic matter content, but there are many actually. Now, to save time, I won't click this YouTube video, but I encourage you to click. After this, you can watch how many ways that you can determine soil organic matter. Yeah. So those are chemistry lah. Learn it by yourself. Clicking it, yeah. Now, most of the time, soil organic matter is determined in the lab as organic carbon. So the easiest way is you burn it in a furnace, completely incinerate whatever the carbons that you have, be it cellulose, be it carbohydrates, cellulose and carbohydrates. They will completely convert it into carbon dioxide. And from the loss of those carbon, we assume that they are lost through carbon dioxide, a gas, and what's left there, the difference before and after combustion, that amount represent the dry weight of soil organic matter. And from the previous studies, scientists have determined that the ratio, okay, the ratio between soil organic matter and soil organic carbon is this. So if you have like 1.72 grams of soil organic matter, 1 gram is the carbon. So that is the ratio that they determine. Well, of course, there are plenty of debates still going on whether this is accurate or not, but so far, for secondary and also university level, pre-university level education, we still stick to this to this factor, okay? Okay, so to know this, whatever the soil organic matter that you have, you divide by this 1.72, and then you have the amount of soil organic carbon. I think you did it before, so I don't need to like explain too much to you, yeah. Okay, next. Now we are going into soil organic matter component. There are 4. And you can see from the proportion, majority of them are of decomposing organic matter or stabilized organic matter. There's 2 small fractions, one of which we have learned 2 days ago, the living organism, and also fresh residue. Now, fresh residue, they could be animal-based or it could be plant-based, but we can say quite safely it's majority of them plant-based, yeah? Okay, so soil organic matter encompasses of all living organisms, dead or alive, both counted under soil organic matter. And then fresh residue actually consists of organic matter. It could be also some waste coming from the animals, which surprisingly, this is manure. Manure comes from, it can come from cow or any ruminants like the goats. It can also comes from chicken as well, yeah. But these two types of manure, they're quite different, yeah, depending on the diet of that animal. Like because ruminants like cow and goat, they usually feeds on grass, so the manure majority of them is cellulose or the derivative of it. Whereas chicken manure, it's a little bit higher on the nitrogen content. Carbon still have, yeah. Well decomposed residue is called humus. So humus is right here. Now humus, I think we have a part that we can discuss later. So I think I'll skip and wait until that. Okay. So the first part they are going to go through is living organism. And usually when you talk about that, it's not too many of them. It's about like 5% or less in weight, in dry weight of the soil. Yeah. Now, this living organism is said to be important because why? These are the organisms that recycle nutrient. Not only they recycle, they spread it as well. And that is why they're so important. You don't need much. 5% is enough. The more, the better. But 5 is the least that you can have. Okay, next one, mostly occupied the surface of layer of soil. So, remembering last time when we discussed where can you find living organism? A place where you can find food, nutrient, sunlight, and air. That is where you can find them. Okay, the size vary from big to small, and I think I will skip that because last time I've explained it, so I'll just skip lah. Okay, fresh residue coming from, like I said to you, the litters of plant. So they can be leaves, they can be twigs, they can be branches that falls down from a tree. It could be even dead organic matter coming from animal or insects. Whatever that is, these are the fresh residue. These are um, fresh means they were dropped from the trees like less than 24 hours, I would say. Less than 24 hours. Not so sure how long, but not too long, I would say, yeah. Now, once they drop on the surface, bacteria comes in, animal comes in, soil biology all comes in to decompose it. Okay, so these are the plant material that are being decomposed by microorganism or any organism larger than that. Okay, and during this process, they will release the nutrient and slowly break them down into smaller pieces, into smaller unit, and these smaller units are the available nutrient, be it the potassium, the phosphorus, or the nitrogen. These are those that are easily available and absorbed by plants. Whereas the stabilized one, there's a big difference between stabilized organic matter and decomposing organic matter. Now, at this stage, it is said that the bacteria, why I say bacteria, because bacteria is the last stage, yeah, the last stage of organism that can break it into smaller part. Because the big part, they were usually broken by larger organism like earthworms, centipedes. Now, the last stage of the decomposition usually is handled by bacteria or fungus, microbes lah, okay? We call it microbes. Now, at this stage, usually the microbes will not have a significant degradation because during decomposition, they will have a very fast rate of decomposition where nutrients is released in large amount. But when they come to this stage, the nutrient release will be very, very small. Okay, so they have like a peak, they go up. Okay, the reaction goes up, and then after that they stop. Because why? Maybe at this stage there's no more nutrient that they can break down anymore. But here's the thing, in humus there is still nutrient. Okay, so don't think that humus have no nutrient. They still have nutrient. The only difference is that these nutrients, they are harder to break down. They are harder to be released. Why? Because in humus, they still have a component called lignin. Okay, now this lignin is part of the organic component inside the leaves or the plants. Now the difference is lignin is very difficult to be break down by microbes. Okay, I didn't say that they cannot break down. They can, but they happen really, really slow. And because of that, they can release nutrient in a very slow way, very low rate. And why this is important? Because when the nutrient is released in a very slow manner, that means there is no risk of eutrophication. There's no risk of eutrophication. And this humus is said to be able to release the nutrient in a very low pace. So humus, why they're so important? That is why. Because they contain nutrient and they release it very slowly. Okay? That is a good thing actually. Okay, so You must have seen this before because earlier when I teach you CEC, cation ion exchange capacity, these are the ones that cause them to have the negative charge. And again, this is humus. This is what humus have and why they're so important. They have this. They can retain moisture because these are the polar functional group. These are the functional group that can attract H2O. That's why they can absorb a lot of moisture. And then the other part is that they also use this one to trap and store nutrient. Potassium, for example, ammonium, for example, they can easily attach this one. Positive charge, okay, negative charge, they have another way, which I've already explained to you earlier. The other thing that you possibly, I did not explain to you during CEC is that the last part. The charge on the surface highly dependent on soil pH, and they have one more function. Apart from storing moisture, apart from storing nutrient, the existence of this functional group can buffer the sudden change of pH. Okay, if you don't know what is that, that means, let's say if there's suddenly a pollution that fluctuates the pH, going too high or too low, now the presence of humus can absorb these nutrients, and whatever the change of pH will be minimal. It's not suddenly change, because sudden change will going to definitely affect the soil organism. So this one actually having the same function as clay, they can buffer the sudden change of pH as well. Now, if you really want to know the real structure of humus, this is how it looks like in 3 dimension. Last time when I show you CEC, the structure is in 2D. That is not accurate. This is accurate. If you turn it around, it looks very much as big as a protein structure. Anyway, don't worry. If you don't know how to draw this, don't worry. We will not be asked to draw these things. Don't worry. But I cannot guarantee this one. Yeah. Let's say if there's any question coming in your test and examination, you were expected to know these things. Yeah. One that I'm circling right now. At least you learn organic chemistry, right? So you should be able to answer this. Okay. Moving on, component of humus. So now even humus as well consists of several fractions. And usually humus are determined by extraction of alkaline solutions. So they will be easily extracted by sodium hydroxide, 0.5 molar. And alkaline solution is said to be able to extract organic components much easier than water alone. So that's why, okay, so you use alkaline solution, NaOH. Now, whatever the components that is not extractable, they are solid, and this one we call it humin. Okay, so they can be determined by weighing, okay, weighing of the dry weight. Now, what about those dissolved? Okay, now those that are dissolved, they can be further classified into two. Those that are insoluble in HCl and the one that is soluble in HCl. Now, what makes them insoluble? Have a look at the molecular weight. You see, whenever that is extracted by NaOH, they can be reversed if the molecular weight is high enough. So this is quite high. And when you neutralize back the pH into acidic fraction, those negative charge will become attacked by protons and they become neutralized. So they have no charge. Now, whatever the organic components without charge, they will no longer soluble. And that's why when you mix acid with the alkaline extract earlier, they can reverse and precipitate organic fraction that is higher in molecular weight. Okay, we have a name for it. We call it humic acid. Okay. So these are humic acid and they have higher molecular weight than the soluble ones, in which the soluble ones, the molecular is between 2,000 and 50,000. We have a name, we call it fulvic acid. Humic acid versus fulvic acid and also humin. So generally speaking, in humus, you have three components. Humin, the insoluble ones, humic acid, the higher molecular weight, and then fulvic acid, the smallest molecular weight of the humus fraction. So three, just three components only. Okay, now properties of humus. Let's start one by one. Again, contributes to improving soil structure and aggregation, decrease bulk density and thus increase the pore space, increase total water holding capacity. WHC means water holding capacity. And it increases heat absorption. Okay, it's actually a whole lump, but I can explain one by one. Beginning with the negative charge that they have. Okay, now, as I told you just now, they have a lot of negative charge from acetate, from phenolates. These negative charge are the ones that can absorb moisture. But this structure actually is quite spirally. They are spiral. Now, these humus are spiral. And because of that, they have space inside the humus. And because of the space, when you mix it with soil, they decrease the bulk density of the soil. Because humus essentially have very low weight. They have space, but they have no weight, virtually no weight. So when they mix with soil, they decrease the bulk density. Good or not? Actually, it's good because it allows the air to come in. Okay. Next one. Now, because of the negative charge, they can absorb moisture. Okay. Now, this moisture will help reduce the heat. Now, moisture, as you know, is water and they have high heat absorption. Because of that, even though organic soil is dark in color, they are not that hot because why? They have water to bring down and absorb the heat. Okay, now with the same negative charge as well, they can also trap positive charge material. Now those are cations. Most of the cations, they are nutrient like ammonium and also potassium and also those trace elements. Phosphorus and sulfur, they can also be absorbed with the help of calcium as the uh, the cations that can attract those two things together. Okay, and apart from that, chemical properties involved by humus involving chelation. Okay, now there is a saying that some of the metals they are not so soluble. Well, I can't say specifically which one because most of the cations, the metals that we know, they're actually cations. Well, if they are completely ionized, they can dissolve. Now, some of those metals, they are still in a form of salt form and they are not easily soluble because they are too big, they are too dense, and also they're too heavy. Any materials in the environment with high molecular weight, like humic acid, if they have high molecular weight, they are difficult to dissolve. But if they have enough negative charge, they can. Now, how does this happen? Chelation means they are surrounded by the organic matter with a lot of negative charge. And in this case, humus is that organic matter. Okay. Now, humus, when they tie with those cations, they may help increase the solubility and indirectly, it also increases the bioavailability. Okay. Now, bioavailability means how much they can be absorbed and uptake by plants. Okay. But usually these are the connection lah. When the solubility of nutrient or trace element increase, when the solubility increase, the bioavailability also increase accordingly. Yeah. Okay, number two, accelerate mineral weathering and aids solubility of plant nutrients from insoluble minerals. So, okay, I give an example lah. Insoluble minerals such as limestone. How does limestone get more soluble? You need acid, kan? Okay, you need acid, and coincidentally, humus can give more acid because whenever there's bacterial activity, bacteria release those acid, and this is how they can help increase the solubility of plant nutrient from insoluble mineral. Okay, last point, has high absorptive capacity for organic compounds and thus reduce the bioavailability of toxic xenobiotics. Now, examples of toxic xenobiotics include pesticide, or whatever the organic chemicals to kill living organism. So these are xenobiotics. Xenobiotics means materials or compounds that are produced by human, okay, and they are toxic. So don't need to look further. Pesticide is usually number one. Now, how does organic matter absorb pesticide? Okay, I'm going to bring you back to the structure one more time so that you can better understand it. Okay, now when you see this functional group over here, These functional groups are considered polar. Why? Because they have oxygen. Oxygen, the presence of oxygen, nitrogen, these are considered the polar functional group. Now, when you look beyond that, what happened to the other parts? The other parts consist majority of them carbon, isn't it? Now, carbon, in this case, they are considered as the non-polar component. So when water comes in, they are not attached to this carbon, but rather they are attached to this oxygen element. So the oxygen part inside the polar functional group. Now, if it's non-polar, they don't like water. Non-polar things do not like water. Why? Water is polar. So water does not attach too well with non-polar component. However, this non-polar component likes non-polar thing as well. And guess what? Pesticides usually are non-polar. So do you know how they attach and how they trap this pesticide? Pesticide usually will going to attach strongly to this benzene ring or any parts that consist carbon. So this is how pesticides are trapped inside humus. Okay? So very much the same like clay lah, except clay is mineral, but humus is carbon based lah, and they're doing almost the same way for the same purpose. So these are the summary of what humus can do and how humus can be beneficial to plants in the soil. Now next I'm going to explain to you what is the sustainability of soil organic matter. Now since we have already understand why soil organic matter is so important inside the soil and for living things for the soil, how do we maintain them? Like I said to you earlier, soil organic matter is not stable. They don't stay forever in the soil. And that is called labile. Labile means they just exist temporarily. Okay, as you can see right there. Due to the constant change and constant changes of microbiological activity, they break down and they becomes carbon dioxide and so on. Okay, they will decline because of this microbial activity. Now the question is, how do we maintain the healthy level? Okay, how do we make sure that there's enough soil organic matter in the soil? Well, there are several factors that we need to learn now. Okay, factor number one, the parent material. Now, this parent material, usually we are talking about what kind of minerals. What kind of minerals are we dealing? So these are examples like sand, silt, and clay. If I use this, they are mainly connected to the texture itself. Okay, so when you talk about texture, they are directly affected by the ratio of sand, silt, and clay. Now, among these three, which one do you think can store the most carbon and why? Okay, now if you don't know how to answer this question, it all comes back to microbial activity. Now, which one do you think that will have the least microbial activity? Still don't know again. Okay, now coming back to the particle size lah, yeah. Between sand, silt, and clay, sand is the one that can retain the least amount of moisture. Kan? Sand, whatever you pour in the water, they all flows down. Now, going back to the other side, the clay. Clay usually absorbs the most moisture, isn't it? Okay, now that is a key. Clay, because they can retain a lot of moisture, whatever the organic material that is stored inside the clay will be completely inundated by water. So when that happens, when those organic matter is constantly soaked with water, oxygen cannot comes in easily. And let's not forget, bacteria needs this oxygen to actively decompose, isn't it? Okay, that is why. Okay, that is the main point why clay, whatever soils that contains more clay, usually will have more organic carbon. So what happened to sand? You can guess it. Sand, no moisture. They have a lot of bacteria, and not plus sand, because they are so porous. whatever the organic material that you have inside there, water goes in, they all flush out. So remember, always remember, if you have more clay, usually you have more organic matter. Okay, drainage as well. Um, I think I have one more thing also on parent material. Now, in parent material, just like what we've learned just now, organic matter easily breaks down with alkaline condition. Okay, because why just now you saw it just now, isn't it? If you want to extract humus, if you want to extract humus, you use alkaline solution. You don't use acidic solution. So another thing that you need to look at is some parent materials also is alkaline, like limestone. So that's why limestone, kan, when you look carefully, especially when you go to any limestone hill, not many organic materials is retained inside because they're so alkaline that whenever there are organic material on top, they easily dissolve and wash out. Okay? So two factors are particle size and also whether those material, those parent material are alkaline. Okay, number two, climate. Of course, leaching is the main factor. When climate is very wet, they can easily wash out by rainwater. And another one thing is, if the temperature is very hot, that also will going to cause less organic matter. Okay, now, coming back to the bacterial activity. If you have less bacterial activity, you will have more organic matter. So, what is the connection with temperature then? Do you still remember whenever you go to pasar, you want to keep all your vegetables or your meat inside the fridge. For what reason, kan? Because at low temperature, bacteria is the slowest, isn't it? Okay. And that is a key here. When you have low temperature in one certain area, those places also can have a little bit more organic carbon because bacteria works very slow. They decompose those organic matter slowly, and that's why you have more. That is why when you look back at Cameron Highlands usually their soil have a lot more organic matter. So temperature also can be one. Yeah. And then next one is management practice. So in this case, it's more about agriculture. And this one is logic, just use logic. You know, if you want to have more organic matter, first thing first is you reduce the decomposition and you increase the input. How to increase the input? You put more fertilizer. Plants grow well. You have more organic matter. But at the same time, if you want to reduce the decomposition, then quite easy. You just put more organic matter or some biopesticide that might help it a little bit. Yeah. Okay, dry matter production. Now this one, SOM increase, however, only in which it remains harvest along the rootness. Would say this one is related to management. Well, okay, now I think this one I can use some examples such as now, let's say if you have oil palm plantation, the dry mass actually comes from the waste of the production, okay, the waste of oil palm production, like the fruit. After you press the fruit, you have those fiber. These are organic matter. Where did they go to? They don't go into landfill. They put it back into the soil. So this is how oil palm estate farmers, they how do they reintroduce the organic matter from the waste, organic waste from other production. So it's an addition because earlier naturally the leaves falls down and these are the source of the organic matter, but you can artificially add dry matter into it by using other means. It can come from the same plants or it can come artificially from other source like clippings, grass that you cut from other places. When they are dry, you can actually reintroduce into the soil and increase the soil organic matter. And then the next point, topography. Flat topography can hold SOM, while steep terrain encourages erosion. I think this one pairs directly with the climate. More rainwater washes away organic matter. And flat topography, they don't have too much of water movement, not much of runoff. And that's why you have more soil organic matter. So the maintenance of it coming relates directly with the management. How do you increase more soil organic matter? Give the plants, whatever the plants on the surface, more fertilizer. Because fertilizer increases more production of biomass, and biomass is your source of soil organic matter. Crop rotation. Now, how does this happen? Now, some of these crop actually they have very short cycle and very long cycle. What they're talking about here is, let's say if you're a farmer, and you're having some crops that needs to be harvested very frequently. Like for example, the jagung, maize, okay, the maize, jagung, or maybe some short cycle crops like your ubi kayu, the cassava. Now, whenever you harvest it, you are essentially removing the organic matter. Now, in this crop rotation, you possibly, if a farmer realize that the soil is getting less and less organic matter, they will switch to a crop with longer duration of the rotation. Like for example, um, paddy cannot be counted that. Usually they involve trees lah, yeah. They involve trees. They will have like crops that will be harvested in a much more longer duration, so that it actually decrease the likeliness of the loss of carbon, because whenever you harvest, carbon will be lost. So when you have a mixed agriculture with a very longer rotation, it keeps the carbon there, okay? Because whenever you have a living trees, you still have the source of the carbon coming down. Okay, next one is tillage. Now, tillage in this case is more towards the loss of carbon dioxide inside the soil. Yeah. So because when you tillage, all the organic matter becomes exposed, and then when they're exposed, bacteria becomes more aggressive in decomposing, and that's why they also cause loss of soil organic matter. So what is a practice that is preferred here? Less tillage. Okay. Now this one still does not tell you what is the best practice, kan? So the best practice is you use less tillage, and better still, no tillage. Yeah. And then last part, of course, you want organic matter, you add organic matter lah. So returning the crop residue. Okay, the crop residue could be, like I said to you, the waste coming from oil palm. Yeah. And then I think this one I will skip lah, because it's just the examples that I've explained to you earlier about tiling, how tiling will reduce organic matter. No tillage is actually the best way to maintain organic carbon and also the overall tilth of the soil. You can read it later. I'll skip. And then I think we are approaching to the last part. Okay. Now, when we talk about soil health, I told you many, many times that the very first indication is how dark is the soil. Because when they dark, that means they have more organic matter. Because for whatever the properties and the benefits that we learned so far, organic matter directly address the nutrient and also the moisture. These are the two major requirements for any living things to happen inside the soil. And more apparently, these are the major requirement for any farmers to conduct any profitable agriculture. Yeah. Because with organic matter, then you have everything else, the earthworms, you have less erosion. Now, erosion is something that I haven't touched, but I will. In maybe 2 or 3 weeks' time, I'll touch about erosion. And coincidentally, earthworms also is said to be helping in reducing erosion. But generally speaking, you must have organic matter first. When the organic matter is there, erosion will be reduced, the fertility will be increased, moisture will be increased, you have earthworms. So this is how you improve soil quality, by just adding soil organic matter. Yeah, a lot of things, a lot of good things will happen. Okay, why should you care about soil organic matter? Now, this one possibly we're talking about the future. The last, all the previous slides we're talking about agriculture. These are their concerns lah, because healthy soil usually leads to stable production of food source. Most of our food are produced by agriculture. So those are the important things that involve. But in future, we might need to consider a few more things. That is the climate. So yeah, soil organic matter related to climate. But how? Now you see, the climate that we're having today is mainly due to human activities. And these human activities is none other due to the production of something. Whatever that you produce usually involve the burning of fossil fuel. And I think during this MCO, you must have seen a few diagrams before MCO and after MCO. Most of people need to stay back, and you can see all those nitrogen dioxide and also sulfur dioxide is greatly reduced. You see, our power plant is still working like in full capacity, but not our factory and also vehicles. And guess what? These are the main reason why we have a climate change today, due to the increase of carbon dioxide plus all those greenhouse gases. It did not happen like 100 years ago. It only happened since the Industrial Revolution. Now, why we are learning about soil organic matter? Because it is said that that is one way that we can counter climate change. Believe it or not, we can, but we have to do it right. But how? Okay. Now, soil organic matter is called carbon sink because carbon, they can evolve anywhere. They can become carbon dioxide. Now, the act of burning fossil fuel is the act of releasing carbon dioxide. And that is the cause of global warming or climate change. Now, if you can grab and capture this carbon dioxide, you need to convert it into something else. So far, people haven't really successfully converted carbon dioxide into something that can store. But naturally, photosynthesis is one way that carbon dioxide can be trapped in the organic matter. And when they are being stored inside the soil as soil organic matter, that is actually one way to counter global warming and climate change. Yeah. So that's why carbon sink comes up, because soil organic matter can store carbon in the soil. By the way, before we go into that further, so far there are two major agreements, international agreements signed by international governments. The first one being Kyoto Protocol. It has been signed like years ago, since 2008 until 2012, and then it has been renewed until 2020. Yeah, not too far away from now. Now it's already May. We have like 6 more months before this treaty expires. So there will be no more renewal after this. So nobody will going to like okay, by the way, actually there is another new agreement that continues with Kyoto Protocol, and that is called Paris Agreement. And in this Paris Agreement, uh, it's actually addressing more of the reduction of carbon dioxide emission by 20%. And well, after this Paris Agreement is signed by national leaders, they were disaster, I have to say. This disaster is due to the change of government head, and these government head, a few of them, straight away they pull out from Paris Agreement. They say, okay, that's it, goodbye. We're not going to stick to this one. So that is the reason why Paris Agreement is still alive, but you can see lah, it needs the cooperation of everybody. Now, the issue of this is because, like I said to you, they are conflict. And what are these conflicts are mainly due to economy. And this is very much the same like the lockdown exercise in Malaysia as well. Now, it's actually a hard decision to make between having to stick to this agreement versus economy, because in order to reduce this emission, as you can see right there, in order to reduce this emission, governments needs to reduce the combustion of fossil fuel. But you cannot do it because from the energy generated, this energy directly contributes to the economy, because with production happening from the burning of fossil fuel, these are the main source of energy that contributes to the production, the productivity of a nation. So if a nation needs to stick to it, they will have to cut their GDP. GDP means gross domestic production, and that is actually the income of a nation. Now, would you like to live less, I mean having less money, to have a better environment? Some countries already say they want it, especially EU already say yes, but do you know which two countries that says no? Yeah, you guess it right, it's USA. Ever since Donald Trump has been elected to the post of presidency, he straight away said, no, we're not going to stick to it, bye-bye, that's it. And so far, that is the major withdrawal. I think there are several others that I'm not too sure, but the major one is United States And you know what's the irony? The irony is that per capita, that means per human being in that country, United States is the worst polluters in terms of carbon dioxide emission. They are the highest, and yet they withdraw. So whether or not this will be succeed depends to be known. So the concluding remarks, how soil management can play a role in emission reduction. Now, in this case, as long as we practice good agricultural practice, no-till, retain soil organic matter inside, we are indirectly helping in reducing the carbon dioxide emission and helps with reducing the climate change. As easy as that. And guess what? This is what Australia is doing right now. Australia says no, they cannot cut down carbon dioxide emission, but they say they're going to do it another way. They're going to ask their farmers to store more carbon into the soil. In other way, they still win. Well, not completely, but they're still helping in reducing the impact of climate change. There is a scheme we call carbon trading scheme. For those who don't know what this scheme is, it's actually more or less like a treaty, and you get monetary incentive by cutting down emission. And guess what? The state government of Kelantan already signed it. The state government of Kelantan already signed it with an organization I'm not too familiar with, in which even Malaysian government also still haven't signed. The state government of Kelantan already did it. Yeah. So I mean, there are many things that you can learn about carbon storage in soil and also climate change, because that is actually the future. Yeah. And don't be surprised that you can earn money by just adding more carbon into the soil in the future. Who knows? Okay, because of this carbon trading. So with that, I end my presentation.